Howdy! This is the final presentation of Team Titanium 22 for the Texas A&M University Endeavor Project. My name is Adriana Hernandez, and these are my team members who are going to walk us through what we have been developing during the entire spring semester. In this presentation, we are going to discuss the proposed flooding reduction ideas and tools for the city of Nolanville, Texas. Similarly to the chemical element titanium, which is the toughest element with high strength, endurance, and low density, we want the city of Nolanville to become a resilient and innovative city. Our team was established in 2019, but at the beginning of 2020, the 11 members visited Nolanville to better understand the community and environmental issues that the city is currently facing. Ever since, we have been developing design proposals and technological tools for the city of Nolanville to reduce flooding, strengthen their community identity, and incorporate smart technologies. We also believe that this project has the potential to continue improving and expanding over the years. The contribution of each major has been the data collection by the urban planning students, the development of a machine learning algorithm by computer science students, sustainable flood mitigation design solutions by the landscape architecture students, and the creation of a web interface and prototype by the visualization students. All our skills combined will help inform Nolanville City Council to make educated, smart decisions about their built environment and reduce their flooding issues.
The flood zone areas located in this map are the areas that we are mostly focused on because they are the ones that require the most attention. After visiting both areas in Nolanville, we found out that they were both located in high-risk flood zones. And both of these areas have high safety hazards because one of them, Area 1, is easily accessible by children, and the other one, there's only one way in and one way out. The natural disasters in Bell County are mostly compromised to flooding and storms, which is why we decided to make flooding one of our main points of focus. The transportation is most people use cars to get around the town. And because of this, we decided to implement trails and other systems for people to walk more and go out on bicycles more.
The first approach of our team consists of collecting road data and understanding the environmental variables that affect the city. The second approach is finding sustainable solutions and low-impact development techniques to correct the existing infrastructure. The third approach is connecting the community together with the use of technology, smart streets, and pedestrian-friendly trails.
As a group, we decided to help the city of Nolanville by addressing the issue of flooding. As urban planning students, our job was to assess the issue of flooding and conduct research that would aid in our project. We next began the data collection process. We selected a few cities to compare to Nolanville. The cities we selected are Humble, Mission Bend, Temple, League City, and Atascocita. We gathered data using GIS data files for each of the selected cities. The GIS data provided information on the location and road names. We randomly selected 40 roads in each city. Next, we determined the variables that could play a role in flooding regarding the roads. The variables we selected are road width, sidewalks, distance to water, material used, and flood hazard roads. In the last steps of our research, we used Google Earth's measuring tool to measure the distance from the randomly selected roads to bodies of water, and we measured the width of the road using this tool as well. Using Google Earth, we were able to see which selected roads had sidewalks and the material the road was made out of, such as concrete or asphalt, while also determining the condition of the material used. To determine if the roads were in the designated flood zones, we used flood maps on ArcGIS. We then recorded our data into an Excel spreadsheet.
This slide is a more in-depth explanation of the variables we used for the road data collection. We used a total of 240 randomly selected roads to analyze. Sidewalks were recorded as present or not to see if there is a correlation between the added strip of concrete and flooding. The idea behind road width is to measure and see if the width or the space of the road contributes to the flooding. Road material was categorized into new or old, asphalt or concrete, and unpaved compacted, each with a score permeability. Distance to bodies of water was accounted for, in particular, to see if there is a correlation between close proximity to bodies of water and flooding. Lastly, flood hazard roads were analyzed to identify correlation, if any, between the flood hazard roads and the variables being researched. The data gathered for the variables was then stored as data points in an Excel spreadsheet so that the computer science team members could begin the machine learning model.
In addressing the flooding issue, our machine learning problem is to classify a road as either a high or low risk of flooding based on 4 different features: road width, sidewalks, distance to water, and the runoff coefficient, which is dependent on the material of the road. Our model uses the data collected by urban planning to train our model and predict which Nolanville roads are at high risk of flooding. This information is then passed to the user interface created by the visualization students.
Before creating our model, we plotted histograms for each feature to visualize the association of each feature as well as to detect possible outliers. We then ran correlation tests to see how much each feature influenced whether our given road would flood or not. Because the correlation between the features and the outcomes was low, we decided to create a classification algorithm instead of a regression. We also created several scatter plots that show the significant overlap of the outcomes. So we decided that a classification algorithm such as KNN would be better suited to the problem than a linear perceptron, because a line would not divide the data accurately. To see how important the feature is to predict the outcomes, we calculated the Fisher scores of every feature. In descending order, we found that the most influential features are road width, distance to water, presence of sidewalks, and last, runoff coefficient of material.
A k-nearest neighbor's KNN algorithm classifies data points using proximity. Data points are plotted depending on the features, and those with the most similar features will be close together in the graph. The algorithm classifies a new data sample based on the majority class of the k closest data samples. That is why determining the optimal k value was the step in creating our model. The 2 classes that we are identifying is whether or not a road is likely to flood depending on the set of features. In this case, if roads using a certain material or a certain width flood, similar roads, which would be nearby due to having similar features, will be classified in the same category. Intuitively, say we have data for a street that we know is flood prone. If we identify another street that also has similar features to the aforementioned street, we can predict that this street might also flood. When it is applied, a Nolanville road data point will be placed, and depending on the nearby neighbors and the road data of other cities, we can identify whether the Nolanville road will flood.
Our team first conducted a 5-fold cross-validation with the training data to learn the optimal k value. We then used this value to train our k nearest neighbor model, along with the data collected from the 200 roads across 5 different Texas cities. We used this model to predict if each of the 40 randomly selected Nolanville roads would flood or not. We found that our model has a 75% accuracy in predicting the flood outcome of the road. Considering the limited size of our training data and the error due to collecting much of our information by hand, this is a reasonable accuracy.
This is our first proposal, which is a green corridor master plan for the city of Nolanville.
The first site that we focus on is called Nolan Creek Park. This area is dedicated to providing more economic opportunities for the community and mitigating flooding. The design does this by proposing commercial and retail buildings with a green plaza space. Our second focus area is the Birdwatch Park. It's located just above the proposed residential area. There are fishing docks so that at different times of the year, the city can stock the pond with fishes and the community members can go and fish as an event. There is a trail and rest area around the whole pond and an outdoor classroom for the community to watch the birds in the wooded areas or learn about the different ecosystems within the site. The site features a detention pond with stepping stones within it to measure the rainfall. The final site that we want to focus on is called Nolanville Square, which is directly north of the elementary school and focuses on community engagement, giving the members a place in the city to come together for various city events. This is a perspective of Nolanville Square. As you can see, there are many different types of uses that can be done with it, and interactive tiles on the ground for different events such as concerts, or just passive recreation with people being able to sit on the lawn space and relax.
Through the described landscape architecture proposals, the city of Nolanville will be able to reduce the major issues affecting the community and increase the sustainability, community health, economic growth, and overall safety of the city. The following phasing plan proposal starts in 2020 with the ongoing improvements of Mesquite Street and East Avenue H. The phasing then escalates all the way up to the construction of new parks, preservation of the existing wildlife, existing vegetation enhancement, and retail development throughout the year 2040. This will become possible through different funding programs such as the City of Nolanville, TxDOT, Texas A&M, Texas Parks and Wildlife Grants, Rails to Trails, and the Texas Leverage Fund for New Businesses.
As visualization students, it is our job to take the data our team has collected and along with the output of the computer science program and turn it into an understandable and usable product, which is a web-based program that allows the user to see which roads in Nolanville are at risk of flooding or not, along with other functionalities. In order to create a web-based application that is different from all the others, we researched some competitors when it comes to flood mapping. The first competitor is a flood education mapping tool. The good thing about this tool is that it has a clear-coded color key and the map is the main focus. What the tool does not have is any interaction between the user and the map and only shows flooding concerning floodways. This tool is also only concerns the District of Harris County. The next competitor is an ArcGIS tool. This tool has good readability with clear flood boundaries, but is not readable by anyone who is not an architect. Along with no interaction between the user and the map, it has not been updated since 2014. What makes our tool different is user interaction with the map, constant updates with active code, and much more. Our web-based platform is named Reify, which by definition means to make something abstract, more concrete, or real. In this sense, we are taking the output of the computer science program and making it readable and usable by all. We decided to go with a dark interface and monotone color palette of orange and yellow, along with sans serif fonts to create a futuristic and minimalist look. To create a successful user experience journey, we analyzed our audience, interviewed members of City Council, and citizens of Nolanville to determine which tool was best fit for them. Next up was to lay out our user journey map to guide us through creating the final product. Next, we created a collection of elements and buttons to be used on the website centralized around our color palette and theme. These elements are implemented into the final product as option panels. The next step was to lay out a low-fidelity prototype to set up UI/UX design and location of interactions. The final phase of design is the high-fidelity prototype, which is still images visually connected to show where animation and possible journeys the user will take when making decisions. Here's a walkthrough. After the user logs into his or her account, the user chooses from filter options. Here, the user chooses to see areas with low flooding, low traffic. They decide on the map style and to view smart parks. The yellow areas are smart parks created by the landscape architects. You can also click on the image to read more about it. The dots represented are points of flooding. Here you can see the road is not likely to flood based on the output of the machine learning program. The lines represent areas of traffic based on the filter options that were chosen. The user can also view their profile, messages between other users, and can scroll down for previous searches. The user can also change settings like language, privacy, and can scroll down to view and share or add events to a calendar that can also be shared with other users. The user can also download the map in various file types and sizes.
The graph shows the projected net value of our overall design. On the left is the existing conditions. There is little smart technology and flooding was a major issue. There is also not much connection within the city due to lack of bike lanes and trails and not many pedestrian-friendly streets or park areas. By utilizing the data from the urban planners and outputs from the computer science team to inform the landscape architect's design, the visualization measures were able to create a website that informs city officials and community members of real-time conditions in the city of Nolanville. This collaboration between measures has led to an informative design proposal. With the city's enhancements, there is a large increase in smart technology throughout the city, and flooding has decreased significantly, making the city safer. The amount of park areas has risen and a clear connection throughout the city has been formed by using bike lanes, trails, and pedestrian-friendly streets.
Thank you for listening to how we can begin to transform any small city like Nolanville into a smart city.